All right, thanks a lot. Hello, Kotlin Dev Day. My name is Bart Enkelaar. I work at bol.com and we're here for how Kotlin helps stave off software engineering entropy. But first, Starship. This is the rocket that SpaceX is developing to get us to Mars. And there's lots of things you can say about this rocket, and there's lots of awesome things you can say about the rocket, and there's lots of dubious things you can say about Elon Musk. But one of the particular things I really like about this rocket was its development process, because this is developed to be one of the largest rockets in the world, and it's the first rocket to be aiming at full and rapid reusability. And if you look at this thing, it's entirely metal, because all the modern rockets these days, they're built with carbon composites because it's the strongest and it's the lightest. And originally when they were developing this, they were also developing it out of carbon composites, and they built like the largest mold in the world to build this huge rocket. But then, well, what's practically like 60% through their design process, they were looking at what they were doing with building all this custom machinery to build these huge layups of carbon composites. And they figured out that in this particular case, if you make the rocket this large, then actually plain old steel is a better case for rockets than carbon composites. So this is actually like the first rocket in like decennia to be made out of steel. Like, all right, they've developed the steel a little bit further this time, but this steel is heavy, right? It's strong. You build skyscrapers out of steel, not planes or rockets. But at this scale, for this case, that material made much more sense for them. So that's Starship. We're here for how Kotlin helps stave off software engineering entropy. We're at a Kotlin conference, but to be honest, I'm not going to be talking about Kotlin that much. I figure by this time, you all have seen quite a lot about Kotlin, and you're wholly inspired to use it because it's awesome. So I'm going to be staying mostly on a more higher abstraction, and then here in the back, over there, we have the K for Kotlin, and that's where we get back to it. So what is the purpose of this talk? It's called something with entropy, and what do I mean when I talk about software engineering entropy? And why do I think this talk is useful? Right, as I mentioned, my name is Bart Enkelaar. I started in 2008 as a software engineer at Topdesk, now since 2014 at bol.com, which is an awesome place to work. Many people from bol.com are here. Let me hear you. Hey! All right, yeah, there you go. And I'm discipline lead site reliability engineering, where I'd love to talk to you about, but also is not what this talk is about. Most of you will know bol.com. We're a part of Ahold Delhaize group. We sell everything from toys my kids love to everything else that's non-food. And all of these hundreds of thousands of packages go through our warehouses in Waalwijk. And you can imagine that all of that's logistics, all of that infrastructure, all those messages need like a pretty awesome IT landscape to keep it running. So we have thousands of microservices and awesome colleagues that innovate in that every day. And if you're looking for a new thing, it's a great place to work. So, why this talk? As I said, I've been a software engineer for about 14 years now, and in that time I've been to a lot of conferences like this, like DevOps, Stagnation, and all the others. And what I always appreciate at these conferences is that you have like pundits and experts keeping court about the right way to write software. And it's all with high quality standards and test-driven development and automated everything. And then I see those talks and I'm like, yeah, this is what I want. This is the way we should be writing software. And then I come back to my job and I see assignments that look like this. And not only do I read code like this, I actually write code that makes me feel like this. And this was a particularly fun SQL statement of like 200 lines long. We called it the iceberg statement because it nested so deep that it was a mountain, and as soon as you touched it, everything broke. So, and I wrote that thing. And I saw those talks on the conferences. And I wanted to do that, but that was not what I did here. So, having that realization of that, oh yeah, and having talks, having discussions at work, I hear arguments like this, which according to the pundits and the blogs and the experts has been like disproved like 20 years ago. But every day in our everyday code, we make considerations. We take the decision to scale back on quality. And of course, that makes sense, because quality, it has a visibility problem. There's like, well, when we're working on software, it's the features that you can advocate to your users that show up as big, flashing billboards along the road. And it's not one set of features, it's more and more and more. And all these features are awesome. That's what they pay us for. That's the value that we want to deliver. But in the meantime, the quality of the software that we write, that's like the signpost that guides you to the future. And maybe it's even like the dot on the horizon that you go. It might even be the road itself. So, when I talk about quality, what do I mean with software engineering quality? What is this thing that I feel we have this mismatch on? So when I started looking for what quality is, at some point I was preparing this talk and I looked it up on Merriam-Webster, and then they said like quality is being of high excellence, and excellence was the quality of being first class, and first class was being of a high quality, and I got back to quality and I was like, no, that doesn't help me. But then I looked some more and I found this nice definition on simplicity.com, which said that something of a high quality is something that is fit for purpose. And I like that. I could work with that. But then, of course, immediately you come to the question, what is the purpose of software? And for the purpose of software, I think the main thing what we can say is that all software should deliver value. But then, of course, we get to this question, what is value? And for value that software can deliver, I found a really great definition by the author of Understanding Software, which said software delivers value if it helps people. And that makes lots of sense to me, because software should make someone's life somewhere a little better. If it doesn't do that, it shouldn't run, it shouldn't exist. So let's zoom in on this software value. How could we define it from the other end? Because we found this definition that the purpose of software is to deliver value, which means that it needs to help people. But what is the software, the value inherent in a software system? Well, I tried to model this, and I came to something like this. That the total value of a software system is the sum of its feature value times its usage times its... So I came to this as a model. So we have the total summation of like a value factor per feature times the usage of its value, and that whole thing multiplied times the reliability of the system. So this is, of course, extremely high over and ignoring all kinds of interesting details. But still, this was something I think we can work with. And I called this my first axiom. Yay! So we have axiom 1, a definition of software value that we want to define. And of course, quality of software is making it fit for the purpose of delivering value. So high quality software should maximize this equation, serve to maximize that equation. And then But of course, systems don't start out delivering value. We need to get value into these systems. And that, for me, is the purpose of software innovation. So the purpose of software innovation is to increase the value that a software system delivers. And I think we can be pretty safe saying that the amount of value that you add to a software is somehow, here it is, related to the amount of effort you put into the innovation of the systems, somehow linearly related to the amount of effort. So that's our axiom 1 and our axiom 2. And now there is, of course, this entire different aspect of software, of delivering value for software, is that there's cost associated to actually delivering the value. And that is the cost of operation, essentially. And just as that we can say that the amount of value that you add is linearly related to the amount of effort you put into innovation, I think we can say the effort of running software is directly proportional to the amount of value that's in the system. As the amount of usage of a system grows, you need to have, you scale it up more. You're exposed to more bad actors, so you need to up your security. You might have a whole different method of scaling that you need. So that is our axiom 3, that the more value you deliver through software, the more effort you have to put into the operation of that software. And as I said, this whole thing is extremely high over, right? We have these 3 entirely abstract functions, axioms that ignore a lot about our day-to-day operation. But already, from these 3 simple statements, you can conclude something really interesting. Because if the purpose is to maximize value, and if the amount of value is directly proportional to the amount of effort you put in innovation, and if the amount of effort you have to put in operation is directly proportional to the value, and the amount of effort is constant, then you get this really interesting graph that all software innovation approach a horizontal asymptote of innovation's velocity. And this, for me, is the heart of why we, as software engineers, should really choose quality. Because I think this is true in a basic sense. And I've seen this happen a lot. Over the last 8 years at Bol.com, I've gone through a cycle of building something new, putting more and more value in it, more and more value, and it slowed down, and suddenly someone called it a monolith, and we all started splitting it up into microservices that all each individually delivered a lot less value, so were a lot easier to operate. And yeah, we could innovate quicker again, but now we had 4 teams on the same value, and then we have a new small, and we build it, and we build it, and we build it, and hey, somebody else calls it a monolith again, and hey, we split it up into more microservices, which of course only adds to the complexity, because microservices are not a way to scale value, they're a way to scale work. And that really works. But that means that you do have to keep adding to the effort. And the success of software systems, I think, depends on how effectively we can limit the impact of this curve. And that is why we should really put this quality mindset first, in my opinion. So let's take another look at this value, at this equation. This was also really highly abstract, and we're talking about value. And there's a lot that can be ignored here, but there's also a lot that can already be gleaned from this simple system, because this is just a product of a summation of a product. So that basically means that maximize each of these arguments, and you're maximizing the amount of value delivered. So what does that mean? Well, that means that we must make sure that our software systems are adaptable, as in it must be easy to add new features. It means software must be scalable. It must be easy to add new users that use these features. It means that the features that we implement must be relevant, as in our users will want to use these features, and preferably also cohesive. Our users will want to use all of these features. And that they must be reliable. And another interesting thing about reliability here is that as the size of disk grows, the impact of this argument grows. So the more value you deliver, the more you can invest in reliability, which is, now I'm talking about site reliability engineering after all, sorry. So we have these 4 high-level, really interesting conclusions from this equation. Right. How am I doing on time?
You have 15.
Right, oh, excellent. Okay, so let's talk about adaptable systems. Oh, right. Since we're 15, any questions so far? So you're saying the more adaptable a system is? Sorry, can you use the microphone? I can't really hear you.
Thanks. You said that the effort to operate a piece of software is linearly scaling with this whole formula, the value.
Yeah.
But I would say it inversely scales with reliability, because the worse the reliability of something is, the more effort it costs to operate. And I would say it doesn't really scale at all with the relevance of features. So I was wondering why you came to that conclusion.
Yeah, so it mostly scales with the usage, of course.
Yeah, I agree. Yeah.
And you're saying it inversely scales with reliability?
Yeah, so you were using that formula as a argument to maximize value, but all I'm hearing is it should be an argument to maximize scalability, and not necessarily relevance, adaptability, or reliability.
Really interesting point.
It's
yeah. No, I'm
let's move on.
Gonna come back to you, and I haven't really dived into the consequences of this particular equation yet, which is what I want to do over a set of blog posts. But hook me up on Twitter, we'll discuss it. I think on a high level, it's more about the summation of the equation. And if reliability would go down, then the total value that you're delivering would decrease. And therefore, the effort that you have to put into reliability also decreases. So that's linear scaling, right? So I think on the whole, it holds up. On a detailed level, I haven't investigated it enough, and I'd love to do that with you. Any other questions? All right. So then, let's go into adaptable systems. So what does it mean to deliver adaptable software engineering systems? Well, I think this is where a large part of many of the conferences, the pundits are setting us up for success if we do that right. You know, things like keep it simple, and things like solid, which is due to an update. And I think Dan North made a good try with Cupid, but I don't think that's the right thing too. But yeah, and things like keeping dependencies up to date, renovate is good. And things like proper test coverage really help us here. So if we add all these factors and try to set ourselves up for success, that helps. But the main question that I use to maximize the adaptability of my systems is this particular question. Can any other engineer at bol.com fix my system within half an hour? Because there's all kinds of fun conclusions in this particular question. I mean, for one thing, it means our CI/CD pipeline better finish within 5 minutes, you know? And it means that it should go to production. So it means that we need to have quality assurance embedded in our CI/CD pipeline and have the right kind of observability on our live systems so that if something wrong goes to production, we can recover from it quickly. But the main point here, I think, comes down to the mental model. And the mental model of software is this kind of superpower that all software engineers share, and actually all people share. But it can also be blinding you from the problems with your code. Because it enables you to think really quickly about the state of your system, about the logic in your system, and that enables you to experiment with it, all in the infinite possibilities of your mind, because you have all the variables on a row, you have all the state there, and you know how things relate, and one thing changes, what that leads to, and then you can make variations in that possibilities, and that can mean that you really quickly can experiment on your code without having to change a line of code. So that can allow you to debug problems really quickly, to innovate really quickly. But we have to consider Murphy here. Like, you will not always be around when something goes wrong. So all that information about what your code goes through should be entirely backed up in your code. And the context, of course. So this could be documentation, comments, but most importantly, in the code itself. But of course, you can't put context for decisions in code, so those should go into comments. And there's things like contributing.md, changelog sometimes, readme. All of that should paint a complete picture as possible of the mental model required to innovate in that code. And this question and this equation is also why I rather dislike this kind of package structure, because I have no clue what this service is doing. So if you group your code in a domain descriptive way, at least you give people looking at your code a head start on what to look for. So, we've discussed the quality, what the definition is of quality, and why we as engineers should strive for quality all the way. And we found that it means that we need to make our code adaptable, scalable, relevant, and reliable. I don't have the time to go into all the others. I might have the time to go into one more. Depends on how it goes. Right, so where we wanted to go is, of course, we are here for Kotlin. So how does Kotlin help us making this whole thing adaptable, scalable, relevant, and reliable? And Kotlin, I think, really helps us with the adaptability in that we can make our code more expressive. So we can better back up that mental model in the code. The scalability we basically get from JVM, I guess. And there is some aspect of relevancy, but that's more about how all these factors are not separate factors at all, but how they interplay. And that's one of the things I want to get into later, is how they are actually codependent on each other. And of course, reliability also comes from having simpler systems. And I really, really believe that Kotlin allows us to write simpler code, just through the expressiveness and lack of craft that the language enables. So right, yeah. Coming back to the conclusion, thanks to Robert for the K idea. We've seen that if we don't push for quality, then all software engineering systems are doomed to slow down, unless we keep investing more and more in it. And Kotlin allows us to stave off this horizon of doom a little bit through keeping systems more adaptable. And through that way, yeah, because one of the most important things I think is that the push to deliver more and more features is not at risk. We all want to make impact in the world. We all want to deliver business value. And our business users also want us to deliver business values, and the POs as well. So there's a whole army of people pushing for more features. So, but given that this might poses a risk of reducing our competitiveness in the future, I really think it's our responsibility as software engineers to push for the right level of quality in our code base so that we can stave off this horizon of doom together and build awesome stuff. So that's it.